Okay, so today we are discussing section 7-4, that is chapter 7, section 4 in your geometry book, entitled Parallel Lines and Proportional Parts. And we're only doing half of this lesson today. I'm 100% sure that I can get it in 2 of these virtual class periods, but I was not convinced that I could do the entire lesson in 1 virtual period. So we're going to do the first half of the lesson today and the second half of the lesson on Monday, which should lead to 2 relatively simple days. Which is never bad on a Friday and a Monday to have some easier days. Okay, so we're starting off with a theorem that's called the triangle proportionality theorem. It states the following: if we have a triangle ABC that contains another line segment DE such that DE is parallel to BC. So I see the picture there. Notice the parallel markings on DE and BC. If DE is parallel to BC, then DE breaks side AB and side AC into proportional parts, hence the name of the lesson, proportional parts. AD is to DB as AE is to EC. In other words, if we look at this top section, AD is to the other part of that line segment, DB, as AE is to the other part of that line segment, EC. So that segment DE is breaking the 2 sides that it's not parallel to into proportional parts. The left part over the right part equals the left part over the right part. Okay? Yellow over green equals purple over blue. Now, the converse of this statement is also true, which means if we are able to show that that proportion, AD over DB, equals AE over EC, if that is a true statement, if that proportion is true, then we could state that DE is parallel to BC. Okay? So both the theorem and its converse are true, which is somewhat useful. We can use it to find missing side lengths in triangles, which is what we're going to use it for. Any questions so far? Okay, so let's see here. We're going to go in and we're going to do an example problem. There are no questions before we advance? All right. Wait. Oh. Okay. So, thank you for that. We are going to do this problem here. Okay. In triangle PQR, that's the bigger triangle in this picture, ST is parallel to QR. We have those markings already on the line segments indicating that these 2 lines are parallel. It says find the measure of PS. Well, PS is marked in this picture with an X. So we're going to use our this theorem, our triangle proportionality theorem, to set up and solve a proportion here. The top piece over the bottom piece equals the top piece over the bottom piece. Okay, we're going to set up that proportion. Because ST is parallel to QR, PT is to TQ as PS is to SR. The top piece on the right line segment is to the bottom piece on the right line segment, as the top piece on the left is to the bottom piece on the left. Okay, by setting up that proportion and by plugging in the numbers that belong in that proportion, 7.5 is to 3, as X is to 2.5, we can cross multiply and solve for X. So as our first check for understanding, I would like you to solve that proportion and type the value of X into the chat, please. Solve that proportion and type the answer, the value of X, into the chat. Good. Good hustle, by the way. Okay. And if you're getting a different answer, hopefully you can figure out why. Okay. Good. So we're all getting the same answer. That's a good sign. Again, when we solve a proportion, we do so by cross multiplying. So we do 3 times x, which is 3x. And then we do 7.5 times 2.5, which is 18.75. The means and the extremes are equal. In other words, 3x is equal to 18.75. And then we finish this problem by dividing each side by 3 to get x by itself. We get that x is 6.25. Now, x is a variable. Variables do not have units. But we're not asked for x. We're asked for the measure of PS. Well, PS is x centimeters long. So PS would be 6.25 centimeters. That's it. That's all there is to these problems. Okay? It doesn't, they don't get much harder. Okay? They don't get much harder. So that's our first example. We're going to go do another one. If you've already got the notes pulled up, you could actually try the other one. Get out ahead of me a little bit and try it and get ahead of me. Any questions on this example before we advance to the next one? Okay. So here's the next one. In triangle PQR, ST is parallel to QR. Find the measure of TQ. So once again, you'll notice that TQ has already been labeled with a variable x. We're going to set up and solve the proportion to find TQ, to find x. That would be PT is to TQ as PS is to SR. Or RS. It doesn't even matter which way we put it. Again, that's the proportion is the two fractions are the pieces of these two line segments. Okay? 15 over x equals 12.5 over 5. Okay? So we'd set up and solve that proportion. That'd be 15 over x equals 12.5 over 5. And we would solve that proportion. Once again, I'd like you to cross multiply and type the answer into the chat. Oh, you're way ahead of me. Okay, good. So we cross multiply. 12.5 times x is 12.5x. That is equal to 15 times 5, which is 75. Then we would divide each side by 12.5. And we get that x equals 6. If x equals 6, then TQ is 6 inches. Okay, so here's your chat bonus question. I'd like you to find the length of PQ. Type it in the chat. Find the length of PQ and type it in the chat. Remember that PQ is a length, so it should have units. Very good. Okay, so we are good enough at this to realize that PQ is equal to PT plus TQ, segment addition postulate, which means that it would be 15 plus 6, or 21 inches. Very good. Okay. Just checking because that could come up in problems and we need to be aware of that. So any questions on the usage of the triangle proportionality theorem? No, it's not actually a bonus question. I just added it to the notes. That's way too easy for me to give you extra credit for. Okay, So now let's look at how we use the converse. Okay. And this problem actually has it's a little bit harder in general because it has a bit more of a conceptual understanding of mathematics, a bit more abstract of an application of things. Okay. Is everybody good on this slide? Does anybody have any questions before we advance? As always, if I'm going too fast, just hang out after. I'm happy to put any of these slides back up for you to get the rest of them written down. Okay. So our final example is going to ask us the question backwards. It's going to give us enough information to check the proportion. And then it's going to ask us if DE is parallel to GH. So we don't know that it is. We need to set up and check the proportion. So the proportion would be piece over piece equals piece over piece. Okay. Now I said piece 4 times. It's not very descriptive. So let me try again here. FH is to EH as FG is to DG. Now, we do have enough information to check this proportion, and that's what we need to do. So we plug in what we know. EH is 3 units. HF is 9 units. Now, I suppose in theory that I should change this to HF instead of FH, but it doesn't really matter. It's the same thing. Okay. But that directions say HF, so let's make sure we're consistent. Okay. The other side, we don't have numbers for, but we do have a relationship. DG is 1/3 the length of GF. So we are not horribly comfortable with fractions. So in chat, tell me, how would we get rid of the 1/3 in that equation? Good. We'd multiply both sides of that equation by 3. When we multiply both sides of that equation by 3, the fraction would cancel with the 3, and it would turn the equation into 3DG equals GF. Now that just makes it less scary. That doesn't help with the abstract portion of this issue. We still need something. We still need to write some length in these purple and blue spots so that we can set up and check the proportion. We do not know either length. What do we do when we don't know a value in mathematics? What do we use? X, a variable. Very good. So we're going to put an X for DG. Okay? If DG is equal to X, then that means that GF is equal to if DG is equal to X, then GF is equal to, okay, thank you for that, Wyatt, 3X, yes, 3X, okay, so 3X. This will allow us to check the proportion. Okay, we don't need actual lengths to check the proportion because we're comparing them to each other, which means the variable is going to get canceled anyway. Okay, so we're going to go and we're going to plug these numbers into our proportion where they belong, and we're going to check to make sure that our proportion is true. So we say 9 is to 3 as 3x is to x, and we're checking to see if that is true. I just noticed I got the letters reversed here as well, so I better fix that. Should be GF. Again, doesn't matter, but let's make sure we're being consistent. Okay, so when we look at those fractions, we're asking ourselves, are those fractions equal? And the answer is yes, they are. The first fraction, the top and the bottom, are both divisible by 3. The second fraction, the top and the bottom, are both divisible by x. And we would end up with 3 over 1 equals 3 over 1, which is a true statement. So since the proportion checks out, since the ratios are equal, our answer would be yes, DE is parallel to GH. If those ratios were not equal, then the answer would be no. Okay, that's all there is to it, folks. That is the first half of lesson 7-4.